Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
So let me explain once again. I have a algorithm. I wanted to find the time complexity of the algorithm. Then we have analyze each and every statement. This takes 1 unit of time. This is a simple statement, takes 1 unit of time. Then as this is a Tn, I am saying then what is this? Tn minus 1. So the total time is this one. So this is Tn minus 2. Instead of 2, we write the asymptotic value, that is 1. That is constant. 1 means constant. Okay. Tn is equals to Tn minus 1 plus 1. So this is a decreasing function. This is decreasing. Tn is equals to Tn minus 1 plus 1 when n is greater than 0. When n is greater than 0. When n is equal to 0, what? It's not doing anything. It's not doing anything. So constant time again. So constant means we take 1. So I have taken 1. Then I have taken this recurrence relation Tn is equals to Tn minus 1 plus 1. Solve this. What is it Tn minus 1? Tn minus 2 plus 1. So substitute that here. Open it. So Tn minus 2 plus 2. The next will be Tn minus 3 plus 3. Then next Tn minus k plus k. Then in this example of decreasing function where it is n minus something, then we have to assume that this has become 0. In the previous example, it was 1. So I'll come to it once again. We have to solve. This is 1. But now it is 0. So this we have to assume that it is 0. So n minus k is equals to 0. So n is equals to k. Right? N is equals to k. So substitute in this one. N minus k is equals to 0. So this is t0. Then n is equals to k. So k is equals to n. So this is t0 plus n. So it is t0 is what? 1. 1 plus n. So you have to figure out, because so many statements are there, you have to figure out and understand everything. Next. For I assign 0, I is less than n, I plus plus some statement inside for loop, then it is calling itself demo n minus 1. Outside for loop, right? Not inside for loop. What is the time? Let us assume this is Tn. Then, as we know, if I consider also, nothing will happen. So the main thing, this for loop, inside that this statement is there. This statement will execute for n times. If you say, why not for loop, sir? Okay, you take n plus 1. Then why not this, sir? Okay, take this one. Then what is the total answer? 2n plus 2. Shall we write 2n plus 2? No, we have to write asymptotic value here. So that is the reason I am avoiding these things. So only the statement that we have to focus. For that I have taken n. Then what is this? Tn minus 1. That is the Tn. So this is Tn minus 1. So the answer is, the recurrence relation is Tn minus 1 plus n. This is the new recurrence relation we got. Let me write recurrence relation. Tn is equals to Tn minus 1 plus n if n is greater than 0. When n is equal to 0, this is 1. This recurrence relation. Solve that. Solve it. Substitution, you know. New thing that we learned just now is assumption. Same, n minus k is equals to 0. So we have to take n minus k is equals to 0. So for all decreasing functions. Same assumption. Solve it. Tn is equals to Tn minus 1 plus n. First one. Then Tn is equals to, what this Tn minus 1 will be? Tn minus 2 plus n minus 1 plus n. Instead of this, we substituted this. See, write n minus 1 here, n minus 2, n minus 1. So n minus 2, n minus 1. Open this. Tn is equals to Tn minus 2, open the bracket, plus. Don't add this, because if we add, we cannot get the answer easily. Let it be as it is. Because as we go on substituting, we will be getting some terms from here. And those terms will give us some series. From series, we can make a formula. So if you get a sequence of terms, series of terms, we can form a formula. Otherwise, you can't make out a formula. Let it be as it is. Don't say 2n minus 1. Then, next, Tn is equals to Tn minus 3 plus n minus 2 plus n minus 1 plus n. Expand this. Tn is equals to Tn minus 3 plus n minus 2 plus n minus 1 plus n. Third one. n minus 1, n minus 2. This is Tn minus 3, Tn minus 3. Continue. For k times. So Tn is equals to Tn minus k. When this was 3, this was 2. So when this is 4, this will be 3. When this is k, so this is n minus k minus 1. Then next term will be n minus k minus 2. Then plus goes on to n minus 1 and n. I am writing only two terms. Two terms this side, then dot dot dot, two terms that side. And don't ask me why I did not include n minus 2 also. There is no space. Otherwise you write n minus 2, n minus 1 and n. We have reached till here. Up to k times. You know the assumption. Assume n minus k is equals to 0. Therefore, n is equals to k. Then, Tn is equals to T. N minus k how much? 0. Plus n minus k minus 1. So, k minus 1. Okay, let us open this one. N minus k plus 1. So, n minus k plus 1. So, how much this is? 0. N minus k is 0. Then let us open this one. So, it is n minus k, minus into minus plus 2. Then plus goes on to n minus 1 plus n. Right? This is expanded. Now, Tn is T0 plus n minus k is how much? 0. 0 plus 1 is what? 1. Then n minus k is what? 0. 0 plus 2 is what? 2. Then what could be the next term? We can guess 3. Then goes on. Then next last term is n minus 1 plus n. So what is this? What is this? 1 plus 2 plus 3 plus goes on to n. It is sum of first n natural numbers. Then this will be T0 is how much? T0 is 1. So this is 1 plus n into n plus 1 by 2. This is Tn. So let me write somewhere here. There is no space. that one, that one. We got Tn is equals to 1 plus n into n plus 1 by 2. So this is nothing but Tn is equals to theta of n square. This belongs to class n square, right? So I know the class, so I am writing theta. If you want, you can write big O also, omega also, both will be right. Right? Big O n square and omega n square also, if you want, you can write. So I am writing theta. Take this one. So you can write on this, right? So you can write on this one. I just remove this. So get this formula and solve this one. Next, I will directly write down recurrence relation. 1 Tn minus 1 plus n square. N is greater than 0 and this is n is equals to 0. Directly I will write down recurrence relation. So you can understand that there are nested for loop inside the algorithm, right? Nested for loop is there. So let us solve this. Tn is equals to Tn minus 1 plus n square. That's the first equation. Then Tn is equals to Tn minus 2 plus n minus 1 whole square plus n square. That's the second equation. Then third equation, Tn minus 3 plus n minus 2 whole square plus n minus 1 whole square plus n square is the third equation. If I continue, Tn is equals to Tn minus k plus n minus of k minus 1 whole square plus n minus of k minus 2 whole square plus goes on to n minus 1 whole square. I have to remove this. Plus n square. Now this is what? Tn is equals to, this is T0 plus this is 1 square. You already know, there I have solved it. Then this is 2 square plus goes on to n minus 1 whole square plus n square. Then this is what? 1 plus, what is the sum of the squares of first n natural number? So n into n plus 1 into 2n plus 1 by 6. This is highest degree term. What you get? 3 n's are there. So this will be 1 plus roughly n cube. N cube. So this is a Tn is equals to theta of n cube. This is approximate. right? Approximately n cube. Take this one. Now from this we can understand that when Tn is equals to Tn minus 1 plus 1 was theta of n. We already solved this. Tn is equals to Tn minus 1 plus n. We got it as n squared. Now this one, Tn is equals to Tn minus 1 plus n squared. We got the answer as n cube. So it means Tn is equals to Tn minus 1 plus n cube will be n power 4. Isn't it? Then Tn is equals to Tn minus 1 plus log n will be theta of n log n. So whatever this term is, f of n is, that getting multiplied by n. Isn't it? See, 1 into n, n into n square, n square into n cube, n cube into n power 4, log n into n log n. So Tn is equals to Tn minus 1 plus root n is theta of n root n or n power 3 by 2, that is 1.5, right? N power 1.5, theta of n power 1.5. Then it means that if it is t of n minus 2 plus 1, then what will be the answer? See, when it was n minus 1 plus 1, so it was n, and minus 2 also I get n only. N by 2 I will get. So because it is taking jump of two values, skipping one value. So n by 2 we get. So it is theta of n only. So it means Tn is equals to Tn minus anything. Let us say some k plus 1. Then also it is order of n. Some constant. So from this we come up with the formula that if Tn is equals to T n minus some value. Okay, leave it. Next time we will see. Take this one. Now, next algorithm, demo n. If n is greater than 0, some statement, then call demo for n minus 1, then call demo for n minus 1. Prepare recurrent solution for this. This is a Tn, yes. This is 1, yes. This is a Tn minus 1, yes. This is Tn minus 1. Both are executed, yes. It is not in if and else. This is not in if and else. Both are executed. So, what is the recurrent solution? Tn is equals to 2 times Tn minus 1. So, 2 times Tn minus 1 plus 1 plus 1. Add all these. So, we got this. That is equal to that actual time. This is a different one. This is a different one. So, now Tn is equals to 2Tn minus 1 plus 1 if n is greater than 0. What if n is equal to 0? It is 1. Again, if n is 0, it's not doing anything. Not doing anything means instead of saying 0, we say constant, that is 1. Or else you can take any variable name also there, C or K or A, any variable name also you can take. So it's a constant. Let us solve this. So Tn is equals to 2Tn minus 1 plus 1. This is the first equation. Then, what is the Tn minus 1? So watch it very carefully. 2 as it is, bracket Tn minus 1. When the Tn is 2Tn minus 1 plus 1, then Tn minus 1 will be 2. Tn minus 2 plus 1 as it is. Then plus 1, this plus 1. Then expand this. Tn is equals to 2 into 2, 2 square, Tn minus 2 plus. This mostly students do mistake here. This is 2 into 1, 2 plus 1. You have to multiply both for opening the bracket. Right? So 2 square Tn minus 2 plus 2 plus 1. Then, this is the second equation. Next, Tn is equals to 2 square as it is. What is Tn minus 2? Tn minus 3 plus 1. Plus these two as it is, 2 plus 1. Open this one. Tn is equals to 2 square into 2, 2 cube, Tn minus 3 plus 2 square into 2, 1. So this is 2 square plus 2 plus 1. So this is the third equation. If I continue this, for k times, so Tn is equals to 2 power k, Tn minus k plus, this will be 2 power k minus 1, because when this was 3, so this was 2. So plus 2 power k minus 2 plus goes on 2 power 2 plus 2 plus 1. So this is the fourth equation we got. Now, what is the assumption? N minus k is how much? N minus k is 0. So since n minus k is 0, therefore n is equals to k. So this becomes what? Tn is equals to 2 power k. So what is k? N, right? N plus, sorry, into t of 0 plus, what is this? You may be knowing that. Right? If you don't know, I'll explain it. First you copy that. That is equal to 2 power k minus 1. So this I have to continue here in this box. I will write down continuation. So Tn is equals to, this is 2 power n into T0 is 1 plus 2 power k minus 1. So k is what? N. So 2 power n minus 1. So the answer is 2 into 2 power n. So 2 into, so 2 times, right? 2 times. So 2 into 2 power n minus 1. So this is theta of 2 power n. Copy everything. So this is the continuation. I have written the answer here in this box. So that's all. I'll remove this. I have to explain this, how we got this. So I'll explain afterwards. Now, listen. For Tn is equals to 2Tn minus 1 plus 1. This was the recurrence relation. We got it as 2 power n. Now, already I told you that 2 power n algorithm we have not seen, but now we saw a 2 power n time taking algorithm. So mostly it is in recursion when a recursive function is calling itself 2 times by decreasing the value, subtracting the value, then it is 2 power n. If it is calling 2 times, so it means Tn is equals to 3Tn minus 1 plus 1 will be 3 power n. Yes. So Tn is equals to 5 times. If it is calling, then will it be 5 power n? Yes. So it means if it is calling itself for n times, then will it be n power n? Yes, n power n. So what happens if I write first one once again? Tn minus 1 plus, instead of 1 if I write n, then it can be n 2 power n. This is one of the solution. So it means this is Tn is equals to 2Tn minus 1 plus n square will be theta of n square 2 power n. Yes. Take that one also. I have to explain this, right? So have you copied it? So afterwards I'll explain. First let us finish the topic. There is a series, right? It's a series. So I will show some series. Now, general form of recurrence relation. Okay, general form, if I take it like this, Tn is equals to A Tn minus B plus f of n. If this is the general form, then we saw that if A is equal to 1, then Tn is equals to what? Can you recall? If this was 1, A is 1 only, then n minus b, b means anything. It can be 1, 2, 3 or k, anything. Then what was the answer we were getting? So that was theta of n into this f of n was getting multiplied by it. N into f of n. Let us write like this. N into f of n. This is 1. And if a is greater than 1, then 2, 3, 5, n. What is the answer? See, if f of n is n, then n is there, n square is also there. So this is f of n as it is, but a power n into f of n. So we got two cases, case 1, case 2. Yes. These are the two cases we got if we have taken the general form. Now listen carefully. From the general form, we understood that for finding the answer for any recurrence relation, we don't have to follow back substitution. Directly we can give the answer. Now, like once we got this one, we gave the answer. For this, we give the answer for this. Like this, we can give the answer for any recurrence relation. Then a recurrence relation may be in this form, and there are two cases, right? So this is nothing but Master's theorem. Master's theorem. For what? Decreasing functions. For decreasing functions. This is Master's theorem for decreasing function. So Master theorem, we got it from our own observation. Yes, we have observed that, okay, this is the answer, direct answer. We were able to find the direct answer. That's what, that observation itself is a theorem here, right? So it is Master's theorem for decreasing function. There is one more Master theorem for dividing function. That we will see it afterwards. Copy that. See, usually we take Master theorem and solve the questions, but already we solved the question, then we are looking at Master theorem. This is the difference. We have already solved. Now we are looking at Master theorem. From the solution, we understood the formula for Master theorem. Then I have to show you this. A plus AR plus AR square plus goes on to AR to the power of K. What is the answer for this one? This is sum of GP terms, geometric progression series, sum of GP terms. So the formula is A into R to the power of K plus 1 minus 1 by R minus 1. This is the formula. Sum of the terms of GP series. This is the formula, known formula. We have already studied this. Then, if this is 1 plus 2 plus 2 square plus goes on to 2 power k, then what is this? Here, A is 1 and R is 2. Then, 1 into 2 power k plus 1 minus 1 by 2 minus 1. So, I have to remove the cases. This is equal to 2 power k plus 1 minus 1. This is how we got it. So, We were already having 1 plus 2 plus 2 power 2 plus goes on to 2 power k minus 1 we were having. So we got it as 2 power k minus 1. So this is already plus 1. If I write plus minus gets cancelled, so I get only k. So that's why I got the answer like this. This is one series. This is the first one. Then one more I will show you. One plus 1 by 2 plus 1 by 3 plus 1 by 4 plus goes on to 1 by k. I will not take 1. Oh, sorry. I will not take 1. 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus goes on to 1 by 2 power k. This will be equal to 1. Alright. So harmonic progression, you can convert it and you can get the answer as 1. So you'll get the answer as 1. So two series you have to copy. This one and this one. One plus 1 by 2 plus 1 by 3 plus goes on to 1 by n is log n. Take this one also. Okay, finish with this. Now, dividing functions, recurrence relation for dividing. These are also reducing the value of n but by dividing them. So this is a dividing function. This is commonly you study in academics. Decreasing is not there in academics. So you might have seen it for first time, and you saw the master's theorem for decreasing. That was for the first time maybe. I don't know if it's there in some university. Then usually it's not there. So decreasing functions are common. So decreasing function. Already we have solved one of them. So algorithm demo n. If n is greater than 1. Till now I was writing it as 0. Now I am writing as 1. If you write 0 also you can solve, but you cannot get the proper solution. So in the interest of getting a solution, we are saying that it is 1. If it is not 1 also, we make it as 1. Okay. So if it is 0 also, we'll make it as 1. So if n is greater than 1, then do what? Do something, some statement, then call itself demo n by 2. The time taken is a tn, then this is 1 and this is a tn by 2. So what is the total? Tn is equals to Tn by 2 plus 1. We already solved this. So what was the recurrence relation? Tn is equals to Tn by 2 plus 1 when n is greater than 1. When n is equal to 1, this was 1. This is the recurrence relation we got it for binary search, right? and we have solved it already. Tn is equals to Tn by 2 plus 1. This was the first one. Then Tn is equals to Tn by 2 square plus 2. This was the second one. Then Tn is equals to Tn by 2 cube plus 3. This was the third one. Then Tn is equals to Tn by 2 power k is plus k. This was fourth one. Then we said that t, we assume this one, right? Assume that n by 2 power k is equals to 1. Then n is equals to 2 power k and k is equals to log n. So we got this answer as a Tn is equals to T1 plus log n. This is 1 plus log n, and the answer is theta of log n. We have already solved. So quickly you can take this. I solved it again by skipping all the steps, so that rest of them I can show you skipping all the steps, right? For I assign 0, I is less than n, I plus plus, some statement. Then call demo for n by 2. What is the time taken here? This is n, this is a Tn by 2. So Tn is equals to Tn by 2 plus n. That is a change. So I'll make the changes. Look at this. This is n, right? That is n. Now already I have it, so I'll just make changes. Watch them carefully. When this is n, then this is also n. The next time, this is becoming n by 2, so this also becomes n by 2. Then this is becoming n by 2 square, so this also becomes n by 2 square. So this becomes n by 2 power k, so this also becomes n by 2 power k. I have just made some changes. Right, that is n now. So next time it will be, oh, sorry, I missed one thing. This is n, so this n will be carried as it is. So this is n by 2 square, n by 2. This will be n by 2 square plus n by 2 plus n. These two will come as it is. Then this is k. As this was a 2, this was 1. So this was 1, there was nothing. So this is k minus 1 plus n by 2 power k minus 2 plus goes on to n by 2 plus n. I'm directly solving it. 2 power k minus 2. Okay, all the terms are, this is n, then that n as it is, n by 2. Then these two as it is, n by 2 square. Then all three as it is, then n by 2 power k minus 1. So this is the terms we got. Now lastly, we know this. Let us solve this one. So Tn is equals to, this is T1, this one is T1 plus, n is common among all. From that side I will take 1 plus 1 by 2. Then next will be 1 by 2 square. Then goes on to 1 by 2 power k minus 2 plus 1 by 2 power k minus 1. This is 1 plus n. I have already explained you this. This is equal to what? 1. So already 1 is there. 1 plus 1, that is 2. So 1 plus 2n, and this is theta of n. The sequence already I have explained. Just now I wrote that will be equal to 1. So take this This is theta of n. So that's all. I have solved two recurrence relations. No more recurrence relation we will solve. This will take time. Each will take some 5 to 10 minutes time. So we'll solve few more. Then we will see Master's theorem on this dividing functions. Master theorem. Then we will come to the topics of divide and conquer, that is merge sort or finding maximum minimum. Also I'll explain. Then quick sort. These are the three topics left. So once we are thorough with the recurrence relation and the Master's theorem, we are able to solve. Most of the gate questions are there from this one. Many recurrence relations are given, right? So one more thing I will tell you, how the gate questions are asked. One more thing I'll tell you. See, sometime algorithm is given, asking you what is the recurrence relation. You have to write recurrence relation. Right means identify which one is correct. First type of question. Okay. What is that first type? Algorithm is given and asking you what is the recurrence relation. First. Second type of question. Algorithm is given asking the time complexity n. Second type of question. Okay. Algorithm is given asking the time. So you should know the recurrence relation and you should know the answer for that recurrence relation. Okay. Once you practice, you can directly give the answer. Then third type of question. Third type of question. Recurrence relation is given and this question is asked. What is the answer for this? Theta. Algorithm is not given. Direct answer. Then fourth type of question. Fourth type of question. Recurrence relation is given and this equation is asked, 1 plus 2 and the answer that we got after substitution. That is also asked sometime. We write it as asymptotically theta of n, but before that, that is also asked. Right? So these are the various type of questions asked in GATE. Then one more thing. When you have the recurrence relation, you can directly give the answer if you know Master's theorem. So more we will see in the next session.